routing protocol. So let's suppose I have a router here, another router, one more router here, one more router here. This is R1, R2, R3, R4. Here 10.10.0.0/24, 10.10.1.0/24, 10.10.2.0/24. And in the LAN, okay, let's take the simple example. Right? Now recall the routing. In the routing, there are three statements. One is directly connected, it will automatically come into the router. When you do the configure, when you configure the IP address on the router, automatically that will come into the router table. First point. Second is either you can put the static entry or dynamic entry, right? So from R1 point of view, if I have the R1 routing table 0/0, 0/1, 0/1, 0/0. The 0/1, 0/0 and 0/0 is the gig interface or fast Ethernet. You can consider anything, but understand the nomenclature. So from R1 point of view, I am saying directly connected interface will come into the routing table automatically. So from R1 point of view, you will have the entry 10.10.0. Let's suppose here the IP address is .1, .2, .1, .2, .1, .2. So 10.10.0.2 directly connected. 0/0, gig 0/0. The next entry from R1 point of view 10.10.1.1 directly connected with gig 0/1. Clear? From R2 point of view, you will have also so 10.10.1.2 directly connected gig 0/1. 10.10.2.1 directly connected with the 0/0. This is the entry that you will get to into the routing table automatically when we configure the IP address on the interface. Right? This is the entry. Now, let's suppose a person is here. A person is here. This is A. This is B. Now A wants to communicate with B. So this A means 10.10.0.1 is the IP address of A, and 10.10.2.2, 2.2, right? 10.10.2.2 is the IP address for B. Correct? So when I initiate a traffic from A, right? PC, laptop or router, they will create a packet. So in the packet, what is the first field? What is the first field? Yeah. Data. Or say na. First field? Data, right? Second is source IP. Source IP is what? 0.1. Destination IP is what? 2.2. Now this frame will come over the wire. Just a second. What is the first field? Data. So that you know, let's directly come to the IP address. What is the IP address? 10.10.0.1, then 10.10.2.2. With this information, apart from that, it will also attach the MAC address, source MAC, destination MAC address, source code, destination code, data, CRC, and FCS. That you know, those are the common thing, right? So the point here is to understand the routing. How does packet flow? When it comes to router interface, as soon as router receives a packet on its interface, it will open a layer 3 header. In the layer 3 header, it will see the destination IP address. Destination IP address is what? 10.10.2.2. Right? It will go to the routing table. And it will ask routing table that can you help me to reach to the destination 10.10.2.2. Routing will say, let me look up my routing table. Router will look up the routing table. In that routing table, do we have information for 10.10.2.2? No. In that case, router will simply drop the packet. At the layer 3, if router doesn't have the information to reach to the destination, router will drop the packet. But at the layer 2, if layer 2 means MAC address. At the layer 2, if destination MAC address is unknown, router, if destination MAC address is unknown, then PC send the ART broadcast to learn the destination MAC address, right? But at layer 3, if router doesn't have the destination entries, it will simply drop the packet. So router will drop the packet. If that is the behavior, then communication will not happen, right? That is why we have the routing protocol. Here we perform the routing. The routing protocol, routing can be performed by 2 ways: static and dynamic. So dynamic is that will come later in the class. Let's discuss the static. So we have to perform the static protocol. In the static protocol means where admin will put the entry into the router routing table. So what is going to happen here? Admin will log into this router. Admin will log into this router. He will go into the config mode and put an entry IP route. Destination network. Subnet mask. Next hop IP address. It's a format. Destination network. What is the destination network here? This guy R2 and R4. This is R4 actually. Means destination network is what? 10.10.2.0. Then subnet mask. What is the subnet mask for this? Tell me 255.0. Last 24 subnet mask is this term. Next hop. if I send this packet to this guy, then this guy knows how to reach, because from that point of view, from this guy point of view, this network is directly connected. So what is the next stop then? What is the IP address here? 10.10.1.2. This is the next stop. 10.10.1. IP route. Into the R1 routing table, you have to give command IP route destination network 10.10.2.0. Subnet mask for destination /24 is this. Then next hop is that where if you send that packet to the next hop will help me to reach to the destination. So if I send that packet on that guy 10.10.1.2, that guy will help me because that is directly connected with the R2. So when we do the entry into the routing table, here we get another entry. Achha, this one will come as a C. C means connected. This will come as a S means static. In the static, we'll get the entry for 10.10.2.0/24 via this guy 10.10.1. Now come once again. When a packet comes, it will look up the routing table. In the routing table, it will check. Do I have the information? Do I have the information? Do I have the information? In the third line, where we have the static entry, router will say, I will help you to reach to the destination. I need to forward that packet to here. That means router 1 will be able to forward that packet to this guy. So the same frame, this frame will come to router 2. Because it had the entry, correct? Now what is going to happen? When it comes to the router 2 will look up the routing table. In the routing table, it will see the destination IP. Destination IP is what? 10.10.2.2. Then it will go to the routing table. In the routing table, it will look up for the routing table and it will see that 10.10.2.0 subnet is directly connected with the this 0/1. This is directly connected with the 0/0. So it will simply look up the routing table and forward here, and here .2 is sitting. When it comes to the router 2, it will see that destination IP address is 10.10.2.2. I am also 10.10.2.2. That means this packet is destined to me. Now router 2 will reply. Sorry, router 4. Router 4 will reply. In the reply packet, in IP communication, source end-to-end IP communication, source IP and destination IP will not change, but MAC address will change hop by hop, right? So now this R2 will reply. In the reply packet, R2 will put its own source IP 10.10.2.2. Destination IP is what? 10.10.0.1. This information will come to the R2. As soon as it comes to the R2, router will look up the routing table. It will open a layer 3 header. In the layer 3 header, it will see the destination IP is 10.10.0.1. 0.1. It will look up the routing table again. Do we have any information into the routing table for 10.10.0.1? No. Router will simply drop the packet. At the layer 3, if destination network is unknown, is not reachable, router will drop the packet. But here, we are not supposed to be happened like that. It should not happen like that, right? So we have to perform the routing. Routing can be done via two ways, static and dynamic. So static way. In the static way, I need to log into this router and I need to put the static entry. What is the command sequence? What is the command? IP route. Then destination network. What is the destination network here? 0.0. We need to put the subnet destination network. Destination network, right? Then what is the subnet mask for this guy? 0. Next hop. If I forward here, is where 10.10.1.1. If I forward this packet to here on R1, then R1 will help me to reach to the destination because that destination is directly connected with the R1. So this should be next hop. Next hop is 10.10.1.1. So here we'll get another entry as static 10.10.0.0 / 24 via 10.10.1.1. This time router will look up the routing table and if we see that to reach to the destination, I need to forward here because this is also directly connected. This is what is the IP address here? 10.10.1.1 and what is the IP address here? 10.10.1.2. Both are in same subnet. That means that is also directly connected. So if I know the subnet which are directly connected to me, I can help routing table to look up the routing table. So it will come to the R1 with the information. Now I have the reachability. It will come to the R1 and R1 will see the R1 will look up the routing table. In the routing table, if we see that destination network is directly connected with the gig 0/0, it will simply forward the packet downside. Correct? So here the main point is you need to understand the syntax to write down the static entry. Static entry, when you want to make a static entry, first of all, we need to go into the config mode. Then IP route, destination network, then destination subnet mask, then next hop. Next hop is the IP address from where you are reachable. You cannot put any next hop. Make sure the next hop if you are putting, it should be reachable from yourself itself. If any chance this IP address is not reachable, and if you are putting from R1 point of view, if you are putting this as a next hop, it is not going to work. Because next hop IP address always should be reachable from your router. On the router where you are putting the static route, from that router next hop must be reachable. If not reachable, then no use of putting a static route. It will be there, but it won't work. Right? There are another way it won't come into the routing table because next hop is not reachable. It won't come into the routing. Clear? So here routing protocol. Achha. Routing protocol, what is the main function of the routing protocol? To communicate with the different subnet, different router, right? So routing, static, dynamic, right? People say default routing protocol, but that is also comes under the static routing. They say static routing protocol, static dynamic default, but default is also comes under the static routing. So static routing protocol and dynamic routing protocol. Static routing protocol where admin put the entry. What entry? IP, route, destination, network, destination subnet, then next hop. IP. You can simply put next hop because sometimes it's up to us actually. If you want to use that, if you want to use the IP address, we can use, or we can also use the IP address. From CCNA point of view, let's go for the IP address. Instead of this IP address, you can also put the interface, right? So it's not 100% correct that you always have to put the IP address. That depends on that, right? Instead of that, you can also put the interface, exit interface. But from CCNA point of view, let's consider this. In the static routing protocol, this is a single command we have to use, right? But in the single command, we have the different formats. Here you can use the combination of IP address, you can use the combination of only IP address, you can use the combination of IP address plus interface. Interface, you can use that. You can use the combination along with the matrix. Matrix we see later. So dynamic routing protocol. In the dynamic routing protocol, we have the multiple protocol. RIP, IGRP, EIGRP, OSPF, ISIS. These are the multiple dynamic routing protocol. Okay. Done. So let's dig into the static routing protocol.